In this first statistics video, we're just going to look at the definition of statistics and some other terms related to statistics. So this comes from section 13.1. Statistics is both an art and a science. It's where we gather data, we analyze it, and we make inferences from numerical information that has been obtained in an experiment. Now, sometimes that information, that data that we collect is numerical in nature, sometimes it's not, and we're going to talk about the two different types of data in just a minute. But as it says, stats is both an art and a science. There are some particular rules about how we go about gathering and analyzing the data, but it is also an art form because within those guidelines, those rules, there is a little bit of wiggle room for, say, how we decide to set up a graph or what type of graph we use to display data. So it is both an art and a science. As you see the definition of data, it says that it's the numerical information because that is typically what we work with, though as we'll see, data may not start out numerical in nature. Technically, there's two branches of statistics. We have both descriptive and inferential. So descriptive is just the collection and the organization of the data, and inferential is, as it states, just making those generalizations or those inferences or predictions from the data. Now, the big thing that I want you to get out of this section is the difference between population versus sample. Think of it this way. Population, okay, is our entire collection. It's all the people or items of interest. So if you think back to probability, our population is like our universe. It's everything that is under consideration. When we looked at the example, we were using numbers like 1 through 20. So all of our items of interest, it wasn't necessarily all numbers, 1, 2, 3 to infinity. Our all-encompassing set or our universe was simply the digits 1 through 20. The same is true with the population. If we're interested in voters, we certainly wouldn't be polling or gathering data on every single person in the world. We may only be gathering data, and our population may be just the voters in, say, the United States. So that would be anybody 18 and older who is registered to vote. So our population is like our universe. It's just our all-encompassing set. Now remember, within our universe, we defined some smaller sets. For example, if our universe were the digits 1 through 20, we looked at the sets of multiples of 2, multiples of 3. The same thing happens with populations and samples. Your population is your all-encompassing set, and your sample is just simply a part of that. So if our population of interest were voters in the United States, then an acceptable sample certainly wouldn't be 10-year-old children, because they are not part of that all-encompassing population. So a sample must be a subset of the population. Now what we do is we gather data on a sample and then use that to make an inference about a population. For example, exit polls during presidential elections are a great example. What happens is random people are asked who they voted for as they exit the polling stations. Not everybody is asked, just random people. Based on that sampling throughout, say, a state, then they can make predictions about which way the state's electoral votes will go, be it the Democrat or Republican candidate typically. Most of the time it's pretty accurate, and when the votes are officially counted, we see that the prediction was accurate. Sometimes, though, not so much. It's not always the case that the prediction made is accurate. If you think back to the election in 2004, if you are familiar with it, that was the Bush versus Gore campaign. It was predicted that Florida's electoral votes were going to go to Gore. After the votes were officially counted, it turned out that Florida actually went for Bush, and that was the decisive votes for the election. So sometimes making predictions on samples, not always accurate. Why is it then that we might want to go with a sample? Well, pure and simple. Samples are faster and cheaper. Oftentimes it's nearly impossible or it's just too time consuming to gather information about an entire population. Not only that, it would require extensive funds. So it is just simply faster and cheaper to go with a sample. There's certain rules about the size of the sample to help ensure accuracy of the predictions made. but ultimately samples in general are just faster and cheaper. So one big thing I want you to get out of this particular section is populations versus sample. Population is everything, sample is a subset. The sample is used to make predictions about the population, and we use samples basically because they are faster and cheaper. In the next video, you're going to look at the other important idea I want you to get from this section, which is the difference in data, qualitative versus quantitative data.